This is our second class about lecture 2. And lecture 2 was trends in local networks. I started this lecture in the last meeting, and the lecture consists of basically one introduction and 4 smaller parts. The 4 smaller parts, one was overview of the wired local area networks and the history of applications and how they evolved. And then was history of the wireless LANs. These 2 parts I covered in the last lecture, which is first class of lecture 2. Today I will talk about the other 2 parts. One of them is 802.15 wireless personal area networks, which includes Bluetooth. And then the other one is home area networking. Home area networking is really an emerging application domain. It's not a technology. But before I go to those parts, I would like to remind you that we don't have any class next Tuesday because I'm traveling next Tuesday. So our next class would be on next Thursday, and that would be class 1 on lecture 3, okay, which is about transmission techniques used in local area networks, basically, and generally in network. Anyways, coming back to this lecture, I can just quickly go over the overheads that we had in last week, just to refresh your mind. This is the summary of lecture 1, which was like 3 sectors of the telecommunication industry, if you want to call. One was the backbone, one was the access to the backbone, and one was the distribution. Okay, and in the distribution, we have in the offices, for data, we have LANs, and for the homes, we have HANs, home area networks. Last week, we talked about LANs, and still we continue that. This week, we talk about HANs most of the time. Okay. Then what I did is that I tried to tell you why local area networks exist, what is a local area network really, and then I talked about traditional applications for local area networks and tiered applications, tiered levels, and beyond that, how you connect to the backbone. And then I started to tell you about the chronology of the LAN, history of the LAN industry, that how did they evolve and what was the intention at that time. That's, to my opinion, I say that over and over again, is the most important part. To understand that how history evolved is a good knowledge in the telecommunication industry, because that's how to predict the future. Okay. Then I talked about evolution of Ethernet, that how they started from thick wire, which goes like 500 meters. Then they came to thin cables, which goes up to 185 meters. Then they came to twisted pair, which goes up to 100 meters. And the reason for all of these moves was what? Do you remember? Ease of wiring, yeah. Ease of wiring. That's very important, okay? Because you want to connect a lot of different terminals to one another. And then we went over like evolution of Ethernet. Ethernet happens to be the dominant local area network technology. So it evolved from like 10^5, and then they changed the cables, and as soon as they came to the star network, which was using twisted pair, they went to higher data rate, like 100 megabit per second, and then gigabit per second. And then at the same time, these days they are trying to add other features to Ethernet. Okay. And then I talked about IEEE 802 standards activities. Okay. 802 is the community under IEEE which does all the standards for local area networks. Most of the standards, almost dominantly all the standards. Okay. And we went over different things in here, and then we started to talk about wireless LANs. When we were talking about wireless LANs, first I gave you the history of wireless LANs, and in there I was trying to put my history based on important issues. And what we saw was that wireless LANs, they started as what? Wire replacement, wherever you have problems in the wiring. Okay? And then they had problems with development of the technology until like unlicensed bands emerged. When unlicensed band emerged, people started to develop real products. And real products came in 1990s, but they couldn't sell because they were not good wire replacement markets available for them. So people started to think about other things. And by thinking about other things, events came one after another. And among the events which were coming, one was around 1997, 802.11 got completed, and service providers, cellular industry, which was a very rich industry, became interested in wireless LANs, which was a poor industry at that time in terms of generating income. And then at the same time, Bluetooth appeared in the market. And Bluetooth happens to be the personal area network that is the title of our discussion, part of the title of discussion today. And then we came to today that local area network industry is really going through a new hype. So originally they had a small hype, they didn't have bands, they came to the second hype, they didn't meet, they came down, and now they are going rolling again up. And when they are rolling up now, people are thinking about consumer products inside homes for home area networks. And also people are thinking about infrastructure using wireless LANs for the two types. One is to access to home. The other one, they call it hotspot. Like you go to a place that cellular provider cannot provide you internet access, then they use wireless LAN. What are those hotspots? Airports, a Starbucks cafe, or something like that. Okay. So you come in the campus areas, like sitting areas, the student unions, and things like that. Okay. So more or less, that was then applications, overview of applications. Then we talked about the standards. Basically, the strongest standards, existing standard. One is traditional 802.11, which goes up to 2 megabit per second. Then there is 802.11b, which goes up to 11 megabit per second. Then is 802.11a, which goes up to 54 megabit per second. Okay. 802.11a operates at 5 gigahertz. 802.11b and original 802.11, they operate in 2.4 gigahertz. As the frequency goes higher, the penetration becomes a little bit less. Okay? We will talk about that when we talk about the medium later on. We have a lecture on the medium. Then I talked about why people go after 802.11, because I told you that today the only sector of the industry that venture shows a strong interest in telecommunications is still 802.11. So why they do that, this is the attraction today. Okay. Then what are the technical challenges and how they relate to the standard activities? That was another subject in there. And this is the place that we finished last time. Okay. So that was 802.15 and WPAN, wireless personal area networks. Okay. I start this part, which is the third part of lecture 2, with a history of the 802.15 wireless PANs. How this, in fact, a standard activity started, and this concept started. Basically, in June of 1997, under 802.11, the group wireless PAN, they started to meet. Do you remember that 802.11 started in 802.4? It was 802.4L. So there is a group, a special interest group, they get together. First they go under another standard, then until they get their own number, official number. Okay. So these guys also started in 802.11 as a special group, WPAN group, wireless personal area networking. And This group was motivated with two activities. One was the so-called Home RF group, which was a group of companies who were manufacturing wireless LANs, but they wanted to aim at home market. Okay. Today in the home market, they use 802.11 without any change. But at that time, they thought that if they want to come to the home, they have to integrate the telephone with the data. And that group was calling themselves Home RF group. Okay. So I have two Home RF. One is Home Space RF, which is generally radio networks inside the home. One is Home RF as one word. That one is the group, which was originally initiated under WPAN in the 802.11. Okay. Then they had another group which was looking for personal area networks. This group was motivated with a project called Body LAN. Body LAN was a project which originally started in DARPA for military application to connect the soldiers together and to the network. The project actually leader was in BBN, which happens to be in Cambridge, Massachusetts. And now is under Verizon. It was purchased first by GT, and now it's a part of Verizon. Now, Body LAN project started. Actually, we have one lecture on that in, if you go to my website, in my workshop in 1996 by Dr. Drissen, I believe, who is the guy who started this thing. I had a workshop every 5 years on wireless LANs. First one was in 1991. Second one was 1996. The third one was in 2001. Proceedings and the news on that is on my website. And that happens to be actually the first wireless LAN workshop in the world, which is sponsored with IEEE. Okay, and a lot of good material if you're interested in that field. You can go and find out. Okay. One of them is the paper about Body LAN in 1996, before June of 1997. Okay. Then, anyways, the Body LAN group was actually trying to commercialize the technology which had initiated in DARPA. At that time, it was very fashionable. Okay. To do that, they had approached 802.11, and they defined a specification. And as soon as they defined their specification, Bluetooth got released, and Bluetooth was a product, chipset, which actually fitted very, very closely with this definition that they had for Body LAN. But anyway, in 1998, January of 1998, WPAN committee defined or published their requirements. Okay? And then when they published their requirement, they sent an invitation for participation to Wireless ATM group, which was a group which was trying to bring the wireless to ATM. Very popular at that time. In 1996, for example, they had their first meeting, and they had in Helsinki. They had like 100 participants. At that time, I was teaching a course in Oulu in Finland, which was on wireless LANs. And wireless ATM was overshadowing my course. I lost a lot of my students, actually, to that course. That's a publicized thing. So I remember it very well. Then Bluetooth group. Bluetooth just got announced. Okay? So they invite them to come in. And we will see the history of that. Home RF group, which was also a part of WPAN activities. Then ECE brand. ECE brand is Broadband Radio Access Network. This is the European standard activities, which a part of that is HyperLAN. Okay. So they are working on local area networks and in general broadband access. They defined IRDA. These are the groups who are defining standards for infrared, for short distance communication to the computers. Okay. IETF, which is for internet, and Wireless LAN Alliance. Do you remember I told you that when the wireless LANs were developing around 1996, they wanted to create alliances. One was technical, one was like marketing. Wireless LAN Alliance is the marketing one. which started around 1996. So they invited them also to contribute. Only two groups responded. One was the Bluetooth, and the other one was Home RF group. They responded to the request from the WPAN group. In March of 1998, Home RF group was formed, and in the May of 1998, Bluetooth, a special group was formed inside the WPAN activities. Okay. Now, then in March of 1999, 802.15 was formed. Up to that time, WPAN was under 802.11. So they formed 802.15 on March of 1999. And they approved WPAN, and they had like 500 attendees, okay, for the Bluetooth group and about 802 for Home RF group. At that time was the first time that the Home RF group stepped back. Home RF group was working on like medium access control, which integrates voice and data. Basically, they were taking 802.11 and DECT, and they were trying to combine that. DECT is a standard for wireless PBX, which existed for many years. They wanted to combine these two and create a new technology, new MAC. Okay? It was very popular before the announcement of Bluetooth. As soon as Bluetooth came under WPAN, they lost the audience. Original deadline that they had for the decision on WPAN was on November of 1991, and in November of 2000, they received approval to take Bluetooth as de facto standard under 802.15. And then later on, since they had other branches, they call it 802.15.1. Okay, that's Bluetooth. Bluetooth specification as an standard. Okay, so that's the story up to here. Today, this 802.15 has 4 subcommittees. 802.15.1, which is now not activated anymore, but that's the one who made the Bluetooth a standard specification. Okay. Then they have 802.15.2. This is a group which only recommends practice. So it's not an standardization. What type of practice? Practice of coexistence between 802.11 and Bluetooth, basically. 802.11 and Bluetooth, they work in the same band. And the band is what? Is unlicensed band. So they interfere with one another. Okay? So 802.15.2 tries to first analyze that, what is going on, and then come up with remedies that they can coexist or even cooperate with one another. It was very active at the time that Bluetooth was at height, but now it has lost its height because Bluetooth has lost its height. Then 802.15.3. 802.15.3 is a subcommittee which is working on higher data rates, both physical layer and MAC layer, for personal area networks. Then there is 802.15.4, which works on low rate WPANs. Who needs those low rates? Like if you want to communicate with the dishwasher or audio, low speed devices, consumer product devices, that we will see in the home networking later on. They had another group which was Radio 2 study group, which got suspended. That was a sort of Bluetooth 2. So this is the status of 802.15 today. Now, so the core in there, which attracted a lot of attention in the past few years, was Bluetooth. Bluetooth was the major hub for the WPAN. The reason that it was a major hub was when it got announced, it came with a chipset. So it was a solution existing. Okay. Bluetooth planning started in 1994 in Ericsson in Sweden, and In 1998, Ericsson, Nokia, IBM, Toshiba, and Intel formed a special group to expand this concept and develop a standard out of that. So before that, they had this alliance to develop the technology. And after that, they wanted to convince everybody else to come to the forum. Why? Because Bluetooth per se is a device that wants to connect variety of consumer products to one another. As a result, if it wants to materialize as a standard, you need to have agreement among all the companies. They attracted up to 1,000 companies to develop their products based on Bluetooth interface, but it still was not adequate. Now, in 1999, they, as I said in the last study, they accepted Bluetooth as version 1B for 802.11, for 802.15.1. Okay. And in the year 2000, when it became the de facto, it got approved. At that year, they had over 1,000 companies which were a part of Bluetooth special interest group. A number of companies were developing blue chips all over the world, like about 100 companies all over the world. I think I told you about that a little bit. One of those companies with like around 30 people was sold around $450 million in Silicon Valley in the year 2000. It was the hype of Bluetooth technology. Okay. And then a study for interference between Bluetooth and 802.11 at that time was at the peak. Actually, we had an invitation because our research is mostly in indoor radio propagation. We were invited by the group as well. The chairman of 802.15 was also working in a company that I told you yesterday, which have like installation in here. President was from WPI. Installation of point-to-points in WPI, WIN data. The vice president was Bob Wiley, which is still the chairman of 802.15. Actually, he will be in the conference tomorrow when I go to see him, next week. Then, at that time, at the year 2000, the forecasts was indicating that there is going to be 100 million cellular phones with Bluetooth chips inside them. This is year 2000. And they were thinking that there are going to be several millions of communication devices shortly using Bluetooth. So it was a very, very major hype at that time. But today the hype has come down. Now, the name Bluetooth and the concept of Bluetooth. When they announced Bluetooth, this is coming from Bluetooth website. They were looking in 3 application domains. One was cable replacement. This is the one that basically is personal area network. The issue is that you have a laptop, you have like notepad, you have like mouses, you have keyboards, and you have joysticks, and you have headphones, headsets, and other things associated to one person, which are around the laptop. And you want not to connect them together with wire. So basically, this is cable replacement. Now, just up front to say what is the problem with that, if you want to connect these things, if you have video application and you have connection, Bluetooth's data rate maximum is 700 kilobit per second. Okay? 1 megabit per second is the transmission rate. With that data rate, you cannot support video. That's one of the problems. That I will tell you now later on. It has impacted the movements today. Then another issue in here is issue of service discovery. When you turn on the things, people have to discover one another. It has to be fast. In Bluetooth, people think that it's not that fast enough. Okay. People are working on that. Okay. The next one is the MAC. MAC for that is using polling is not fast enough. So if you have a good physical layer with that MAC, still you will not be able to do certain applications. Anyways, this is cable replacement. The other application that they were thinking about was personal ad hoc networks, which is communication among laptops and notepads. This application shares with the wireless LANs. Wireless LANs have ad hoc networks. They do the same thing. Okay. The third one that they had was integrated voice data access point. 802.11 in terms of data has like access point that you can connect to the backbone, but Bluetooth has better MAC to support voice. But today, a lot of companies, they have voice over IP over 802.11. So in this in fact market, 802.11 shares the same things that WPAN does, according to the original vision. So among the three applications which was considered by Bluetooth at the beginning, to my opinion, only one of them is the one that may be fully compliant with Bluetooth. And that's the cable replacement. The other two, they have the competitor, which is 802.11. Now, coming to the WPAN hypes. The idea of WPAN, as I said earlier in the history, started around 1996. It had a little hype for the body LAN, and then it came down. Then again in 1998, it started to pick up another hype, which was expected to happen around 2000, 2001, but suddenly it started to drop. This hope was for the market, for Bluetooth. This hope was for like body LAN type of application. And then today is just merging to a constant, in fact, slope. And motivation today is to go for a completely new solution, which is better than Bluetooth. That complete new solution that they are talking about is a Bluetooth which has wider bandwidth, has faster service discovery time, and it has a better MAC. So they are designing completely new concept under 802.15.3. So they do a new MAC, and they are looking into different physical layers in there. So if you look at 802.15, the attractive features of 802.15 today are as follows. 802.15.1, which is Bluetooth, people are interested in that because Bluetooth is an existing chip. It's true that it didn't meet the hype to sell billions, but still people are developing their products around that. Okay, because chipset exists. You can develop application around that. Okay, so it's not dead, it's alive. But it has come up to a very steady state, which is below the main hype of expectation. Other features, other than having the chipsets, okay, 802.11 also has chipsets. People were expecting that Bluetooth has less expensive chipsets. But that expense goes with the market. The market has not developed so much that that expectation is really happening. People were thinking about something like $5 per chipset, or even less than that originally. But I don't think it has happened yet. Okay, but people have developed the application. Who developed the application? People who have developed the chipsets and they don't have any market. So they turn it to some products. The other attractive feature of Bluetooth is that it's polling based. It's suitable for voice application because it's a sort of polling time division multiplexing, very similar to time division multiplexing, but it polls. Time division multiple access, you poll one time and then everybody has their slots, but you have to be synchronized. In here you synchronize every time. But it's suitable, since everybody has its own turn, it's suitable for real-time applications like voice, which has a steady data rate. So quality of the voice actually is very good for Bluetooth. I had a demo on that last year in the class, but in this class, since it's on the TV, I just skipped that. Now, another feature of Bluetooth that people like is ad hoc networking support. It has automatic device discovery, and it has the possibility to allow one device share several connections. As a result, it's more suitable for ad hoc networking. Ad hoc networking in 802.11 is just point-to-point, in a sense. This one has more capability. Then, for 802.15.4, people are interested in that because it's focused on low-speed home networking appliances. So it's alive. It was always alive and steadily going on the side with all the hypes. 802.15.3 today is the hope of this industry. And in there, as I told you, they are looking for more efficient MAC layer which can provide better quality of service for voice. So they are looking for something which is TDMA based, which is similar to cellular systems, rather than like 802.11, which is what? CSMA based, which is like Ethernet. And then at the same time, the same subgroup, 15.3, is working on physical layers to support higher data rates. And one of the most hopeful technologies to provide higher data rates is ultra-wideband. And as I mentioned in one of the previous lectures, today 802.11 and ultra-wideband, up to this past summer, were favorite of the venture. And still I think it is as of today. Now, yes?
What is TDMA? That's the picture.
Time division multiple access.
Oh, okay. Thank you.
We will see them later on in the course in more detail. So what is good about ultra-wideband, which is a new technology which is emerging? Number one, it provides data rates which are higher than Bluetooth. Who needs higher data rates? Video applications. Okay. Bluetooth can support up to 7 active users. Ultra-wideband can support many more. And association time of Bluetooth is slower. So with the new MAC that they want to do for the 802.15.3, they assume that ultra-wideband can have faster acquisition. And ultra-wideband also has an edge over Bluetooth in providing more accurate positioning, measure of the distance. So these are more or less applications or motivations that people think are good for ultra-wideband, and it's over Bluetooth. So this is the story of WPANs. WPAN started with the Bluetooth. Today they are shifting toward ultra-wideband, but yet they have not shown any solid market. Bluetooth has like a steady market right now, but very much smaller than what they were originally thinking. And ultra-wideband is a hope of the future. Technical challenges which faces 802.15 or WPAN industry, one is coexistent, that we talked about that before. if you're thinking about Bluetooth, Bluetooth and 802.11 interfere, so you want to model the interference, and then you want to find mechanism for coexistence between 802.11 and Bluetooth. For the new Mac that they are designing, the challenges are to provide quality of support, quality of service support, which means that a medium access control which is similar to the telephone networks, which is time division multiple access type. Okay? They want to have faster service discovery or faster association. They want to increase the number of users. For physical layer, they want to support higher data rates which are needed for video application, which is something above like 25 megabit per second. So that was a story of the two technologies. So far I told you three different types of technologies. One was wired LAN technologies, which basically turns to what? Ethernet. Ethernet is the one which is the dominant today for the wired LAN technologies. Then I talked about two wireless LAN technologies. One was 802.11, which is wireless LAN, and the other one is 802.15, which is what? WPAN. Okay. So these are technologies for local area networks. Dominant technologies today for local area networks. Now I want to shift the gear to home area networks, which is an emerging application domain. Application domain, as I told you earlier, and I have underlined that many, many times, in telecommunication industry is very, very important. And one of that application domain, I call it HAN. But basically are applications which mostly happen inside home, but they may happen in the other places. They are driving most of those substandard committees that we have seen. So when you go to those substandards of 802.15, 1, 2, 3, 4, or you go to 802.11, G, F, I, etc., they are motivated by certain application, each of them. It's not that there are a bunch of scientists in there. They're application developers. Those applications, if you put them all together, you can call all of them HANs, because applications which are away from application traditionally used in the offices. Okay. So as a result, I talk about home area networks. Meanwhile, there are a bunch of companies who are only developing home area networks. One of them is Ucentric in Massachusetts. Actually, they had some research work with some of our faculty in here. There is like Linksys. Linksys has products, very popular, two-wire, but Ucentric is like visionary, next step. Ucentric started, I believe, in 2000. Two wires, Linksys, those guys started in 1998, something like that. These are the companies that they take any of these technologies, they develop products to sell outside. Okay. Now, what are the technologies that they use? Are some of these technologies that we mentioned, and some additional technologies or modified technologies. Those are what I want to see. But the whole domain is an application domain, which is emerging. Now, so what is a home network? Basically, home network, when we are in the home, we have two parts. One is access. Access to what? To the backbone. And then inside the home, I have a bunch of devices, variety of devices, very diversified. And I want to connect all of them together. This is the story of home networking. Today, they are not connected together, or some of them are connected, some of them are not. They are fragmented. I will show some of those networks later on. But let's first look at the home networking and see what is new about it. What is new inside the home? That's the first step that we want to take. This overhead is categorizing variety of applications which need networking inside home. Starting with home computing. Home computing your desktops, laptops, printer, scanner, quick cams. Today, you take all of these things more or less in the same room, you connect them together. And in the same room, you bring the internet. What people want to do is that they want to make it a little broader. So when when the network comes in, goes to your cable modem. After that cable modem goes to another box, which they call it home router. And home router now can connect variety of people with variety of ways. So I can have my laptop in front of my TV in the first floor, and I have my PC upstairs in the second floor when the cable comes in. Okay, that's typical thing that we have today. And they have products for that outside you can go and buy. Okay, and actually I'm using one of that in my home for the application that I told you. Everybody uses that these days. Then, so this is, I call home computing appliances, if you want to call it. Already existing. And in the future, we are expecting that we have more devices in the home, because number of these guys are going to increase. The second, in fact, application domain or appliances inside the home are phone appliances. Today, if you look at the home, inside the home, you have standard telephones, you have cordless telephones, you have intercoms, you have your cell phones. All of them are phone appliances. Cell phone uses a different network and connects to the outside. Your cordless telephone is not a network really, it's a point-to-point connection inside home, but it connects to the backbone, which is public switch telephone network. Standard phones similar to the cordless telephone. Intercom is a sort of network really. It's private network, local area network, because sometimes you have several of them talking with one another. But not many people are using intercom. So it's not a very popular product anyways. So these, we call them phone appliances. Phone appliances are connecting to a different place. These computing appliances are connecting to internet. These guys are connecting to what? To PSTN, public switch telephone network. So these are distribution for public switch telephone network. These are distributions for what? Internet backbone. Then we have like security systems. Security systems are really a network right now because there are a bunch of parts in there, like motion detector, door pins, system controller unit, or cameras and alarms. All of them are connected to one another. Actually, a bunch of them are using wireless solution in there. Okay? So this is a network right now. How do they connect to the outside? Through what? Today, mostly they are connected to the outside through public switch telephone network. They have a private network of their own which monitors the state of the security system inside the home, but that one is like a virtual network. The real network which carries the information is public switch telephone network using what? Using modems. So it's similar to that banking systems that I told you in the old time, which infrastructure belongs to PSTN, but I have a virtual network on top of that using modems. Okay? So this is another network inside what? Inside home. Then I have like entertainment, audio-visual appliances. I have like a stereo system, a lot of parts in the stereo systems. I have DVDs, I have tape players, I have like a CD player, I have equalizer, and then I have speakers. And when I look in the behind them, that's another snake house. First time when I moved to my house, my current house, it took me 6 months to put together my stereo system. But I don't have time to sit down there for 2-3 hours to put all these things together. Usually I'm on the road to the airport. So here we are. I would love to have something that as soon as I turn it on, it works. So this is a very, this is a network in a sense, but it's not a standardized network and it's not wireless. Okay. I want to turn that. Also, this is not connected to any networks. So in the future, I want to have audio stream, video stream. I want to have my TV to pick up something from the web. Huh? And I want to have audio streams. Like go to the web, pick up something, and I play all over the house. So the concept of networking for entertainment devices is changing in twofold. One is I want to go away from too many wires. One is that I want to connect to audio and video streaming, which is the direction of the future, connect to internet. Then I have some bunch of equipments which are not networks. One of them happens to be utility devices. Today, I have electricity, gas, fuel, water, and every month somebody comes to meter them. They want to put something in there which is connected to network, and they avoid somebody to come. When somebody comes, it's very expensive, and people don't like it. So as a result, people are thinking about automating that and connecting that to the internet. So I need some technology for that, which is very low speed. That's 802.15.4, which is approaching to this type of applications. I want very low power consumption, very low data rate, but connection to the internet. Then another thing which is happening around is development of smart appliances. Ovens, fridge, washing machines, today are disconnected to everywhere. But people see that in the future, my refrigerator is going to be connected to internet. Okay, for two purposes. One is that GE wants to check the filters, and if it's not working, send somebody to fix it. And more aggressive people, they assume that a Star Market will put a web camera inside there to check your stuff. And when you don't have grocery, they bring it and they deliver it. And then they have, see, when fever comes, everybody tries to blow up their imagination. So they think that your, like, microwave oven will be connected to the network too. So you're sitting in your car and you're coming home and you start to cook your stuff. Warm it up as soon as you arrive. I mean, for 2 minutes, I don't know. Very, very visionary. Too visionary. I told you that the story of the palms next to the beach and the wireless LANs. That was the slogan of most of the standard activities. That's why you need ad hoc networks. They had this model that people are sitting in the beach and they have like their laptops and they want to communicate. Okay, that was very typical in a standard organization. Like Hyper LAN WAN, always they were announcing that one. And then people were puzzled that who wants to get the laptop in the beach? The sands goes inside, I mean the keyboard, and it's very dangerous actually. You don't want to do that. But anyways, that's a visionary thing that people go after. Anyways, the same way they think that washing machines and everything. But for repair, certainly they need that. For repair, that connection is very good. So these are like smart appliances. It's not far away. People are talking about a small home. In Europe, every city, in Oulu, for example, that I go, they have like smart homes. Inside the smart homes, they have smart appliances. So they have demos in technical parks about the smart homes of the future. I think Bill Gates has one of them. Now, then another technology around these things which is evolving is location and navigation type of application. So they assume that you have tags on your like children, and even further than that, if you have like a blind person in the house, she has a headset and they can navigate him inside the building. That this is a stair, this is a wall, turn right, turn left, things like that. They have applications like that that people think that they may emerge in the future. Today, in that domain, they have like the so-called invisible fence, which they use for the dogs. Okay? So you have like an electronic fence around your building, and you want to keep. Now they want to network that. So if you want to use it for children, you know where are your children. Or from other places in the home, you can see them. Things of that nature. So all around when I look at here, I have variety of like applications, most of them not applicable to the office environment. Okay. The other difference is that in here I have very, very low speed and multi-channel video, which is very, very high speed. So very diversified number of devices, very diversified bandwidth requirements. Now, in order to connect these things together and connect them to the backbone internet or public switch telephone network, okay, I need new technologies to evolve. And that's, some people think about that. Bandwidth requirement for this type of applications, smart appliances, utility metering, security systems, up to some 10 kilobit per second is more than enough for them. If in security system you want to handle video, well, then you need like, let's say up to 1 megabit per second, because you don't want very like high quality video. Phone appliances, usually the traditional ones up to like 64 kilobit per second. And if they are speech coded, like 10 kilobit per second. So between 10 to 60 kilobit per second. If you go for real audio, G2, then a little bit higher data rate. If you go MPEG-3 audio, a little bit higher, but it's still under 1 megabit per second. If you go video games, normal video games, under 1 megabit per second. If you go for printing, under 1 megabit per second. Internet access, well, if it is a little bit above 1, up to 10 megabit per second, this is perfect. Even in the offices, in WPI, you have to ask for 100 megabit per second connection. Otherwise, default is 10 megabit per second. The only place that you need more than 10 megabit per second is if you are using videos. If you have MPEG-2 videos, they have a variety of rates between like less than, several megabit per second up to 60 megabit per second. If you go 3D games, between 30 to 60 megabit per second. Camcord, like 25 megabit per second. All of these guys are above 20 megabit per second. So basically, you have a line in here, 10 megabit per second above that. Today, both for the local area network industry inside the home and wireless local area network inside the home, you have at least transmission rate of 10 megabit per second. Okay? So for next generation, when you want to support video, you need to have new technologies. So that's one of the drives. So people, when they are talking about like higher data rates, what is the application domain? That's because of these videos. Which type of video? When I want to connect to what? My cable TV, for example, make it like wireless. And when I want to have like 3D games, or when I want to get my camcorder, communicate like wirelessly with my like TV monitor or my computer. Those type of things, the existing like 802.11b is not effective. It's 11 megabit transmission rate. The effective data is much less than that. So for that, that's a domain, that's a place, that's a motivation. Who is addressing that? For example, 802.15.3. See, the technologies, the group in there are sharp around those type of things. And also, so for the video, most of the time they say distances are very short. So they go for ultra-wideband, for example, which doesn't have a very wide coverage, but can provide higher data rates. That's the perception today, which is peak of ultra-wideband. Okay. But make it and break it is applications which have like video in them. So if I come inside the home environment, I saw this wide variety of things. In summary, I need like certain technologies to support home networking. One is home Ethernet for computing appliances. What do you mean by home Ethernet? Why not Ethernet itself? Because Ethernet itself works on twisted pairs. Most of the applications are in better quality wires, but except that, they don't have any telephone on that. When you come inside the home, you have telephone using that twisted pair. So if you want to use the same twisted pair for Ethernet, you cannot, because they interfere. So you have to modify Ethernet slightly. That modification is HPNA, that we will see a little bit later. This is home Ethernet, if you want to call it. Then another issue, another need that you have in the home environment is integration with voice. Because voice appliances in home are plenty, and they have cordless telephone also inside the home. Inside offices, we don't have cordless telephones often. But homes is dominant with the home. So as a result, I need like a wireless technology to address the voice. Next one is for entertainment systems, which I don't have them in the offices. I need very high data rate cable replacement beyond Bluetooth. Okay. Then for my utility metering, appliances, and security system, I need very small tags like RFID tags, which are consuming very little power, and they communicate at very low data rates. That's another technology. Who is addressing that? Again, 802.15.4. Okay. In addition to that, if we look at that visionary thing, which is positioning, indoor positioning, which is useful for ad hoc networking and also for positioning itself. For both of them, it's useful. For that, there are a bunch of smaller companies which are evolving around. Some of them in Massachusetts, some of them in other places. And I have a little bias on indoor positioning because that's my area of research currently. Now, so that's, in a sense, the type of technologies that they need, and that those are the places that they are evolving, either in 802s or in these startups. Now, to have just a general overview of like broadband home networking, if you want to call it, you have, as I said, two sectors. One is connection to the home. One is like distribution inside the home. What I was talking about so far was distribution inside home, devices. How about the connection? Connection to home today mostly is wired, and cable modems are the leading ones. Then is DSL, and in places that they are not around, people are using modems. At the same time, 802.11 for access in the places that these two are not available, and 802.16, which is LMDS, and direct broadcast, digital broadcast satellites. Okay, this one are the three wireless solutions that they are emerging. People are evaluating them. These are for bringing the internet to home, which is what second sector of my industry, access industry. Okay, I had three parts. One was the backbone, one was the access, one was distribution. These are about the access. These are a variety of type of access to home. In addition to that, these cellular networks, they are also accessing the home. Okay? Differently, they provide another means for access to the outside. Today, each person at home for any application has one of these things, here and there, differently. For example, some people have cable for the TV, they have DSL for the data, or they have modem for data. They have a mixture of these things. Everybody has their cell phone inside the home. Okay, and these are a bunch of isolated networks. In the future, they want to combine them. That's the research in the home networking today. I will have that with pictures a little bit later. Now, home networking initiatives. which means the standard activities. As I hear and they told you, for distribution systems inside the home. That one was access, not distribution inside the home. I have several options. One is I can use 802.11. I can use 802.15. I can use HPNA, that now you know what is HPNA, Home Ethernet. Okay, detail a little bit later. I can use power line modems. What is that? We will see a little bit later. Or I can use cables which are inside the home for TV. But if you want to have a distribution system, how many, cable TV goes either to one room or at most two rooms. Okay, power line goes several per room. Telephone jacks goes at least one per room. So nobody is thinking about cable to be used as a medium for distribution. For access to home, that's excellent. That's the leading one. But for distribution inside, that's not good. So leading ones are HPNA, power lines, and 802.11, 802.15. On top of that, when I have very short distances, just the office solution, Ethernet itself, which I can add to these things. Okay. So that's about like, actually I can add that, maybe later on. You can add that to here. Ethernet, traditional Ethernet also, for shorter distances. Then, so I have diversity of distribution systems, variety of distribution systems. Inside the office is not like that, Ethernet and only Ethernet. Inside the home, I have different distribution systems and standards. So when they want to do a home router, design a home router, they have to consider that it's compliance with several different standards. But if I have an office router, I have less diversity in there. Okay. Then you come diversity of interface for the standards. Most of the computing devices which are in offices, they have limited number of standards to confirm with. But when you go for the home security devices, they have these standards. ECE506, CBOS, ECE709 LAN board. A smart appliance have a different. Part of that is the LAN, part of them is RAP. Audio video, they have IEEE 1394 and HAVI. Positioning, they have different companies developing different technologies. For each of these guys, when you want to communicate, interface between them, you have a different interface. Okay, so you have different interfaces to accommodate, and you have different distribution systems, the standards to accommodate, which makes this thing a little bit more complex. Now I will tell you a little bit about just technologies. This home PNA, how does it work? HPNA works with on the same twisted pair wiring that you have inside the home. How does it work? What they have done is that these are POTS, telephone, plain old telephone system. POTS are working between 20 hertz up to 3.4 kilohertz. So they are playing in here. Then between 25 kilohertz up to 1.5 megahertz, you have DSL services. DSL is what? DSL is home access. Okay? But still, when it comes to home, it will interfere. I cannot use the wiring in that frequency. So for HPNA, they have selected 2 megahertz up to 30 megahertz. Between 2 and 30 megahertz, they get the Ethernet, just they shift the center frequency to this place. Okay? So what do they do is that you have like a device, whatever, computer device, for example, and it has an Ethernet card inside that, and you have a connection to Ethernet card. That connection comes to an adapter. That adapter changes the frequency to the frequency of HPNA. Then it goes to the telephone jack. Okay? And then inside the home, it's on there. At the other end, it comes to that adapter, lowers the frequency. As a result, if I have like a computer, I use the same network card, the same LAN card. It's very important because that LAN card is already available and is inexpensive. The important point is in its expense. So the same $35 a piece network interface card exists all over the place. Okay, so that's the ideal situation in the future. How about the telephone? Telephone doesn't have any adapter, directly gets connected. Okay, so I have like data on the higher frequencies, on these frequencies, voice on these frequencies, both of them living together on the same wiring inside the home. Okay, so this is one solution, HPNA. The other solution is like power lines. Power lines, I have this power wiring all over the place. I get tempted to use them. But why I cannot use them? Because power lines are very noisy. They are just like the free space. Very, very noisy. Unbelievably noisy. Okay. And then they have another problem. If you go to the frequencies that AM radio works, if you communicate over power lines, it interferes with the AM radio. So FCC won't let you do that. So basically what they do is that they have two bands. One is low bands for low data rate systems. One is high bands for higher data rates. But when you go to high bands, you have to use complex modems. It's become very expensive. Okay? But still there are some companies, actually one of them in Cambridge, which was there since like mid-1990s or early 1990s. They're designing modems for the power lines. That's before HPNA. Okay? But these modems are going to connect higher speed devices, like computers, using upper frequency bands in the power line. But these modems are very complex and expensive. Okay? The other one is, if you come to the lower frequency bands, under AM, okay, you can have very low data rates. What is good for those? That's excellent for my applications, like control devices, controlling TV to turn it on and off, not changing the channel. Or I'm just controlling that from distance. Turning on and off lights, turning on for the appliances, for security system, that's perfect. Okay? What they do is that at those low frequency. Now it has one advantage actually over twisted pair at low frequencies. The advantage is that when you come to the appliances, people want to plug in just one wire. Okay? So now if you, instead of power line, you use like telephone, you have to connect it in two places. So when I want to have my dishwasher, I want to plug it in one. I prefer to have one plug. So power line becomes more popular and more attractive for those type of applications. So this is a technology which is still evolving. So how do they see that? They see it like I'm sitting in Paris inside a conference and my alarm system brings a signal that there is something around the house. The sensor is on. So then I turn on the lights in the basements and other to distract people to run away. That's the type of typical scenario that they talk about. These are scenarios that people really talk about. Okay. Now, so today's home networking, I told about the solutions for distribution. I told you about the solutions for connection to the home. Then, if you look at the home networking today, these are really my concluding remarks. Today, home networking is fragmented. Security has its own system, uses public switch telephone network. Data has its own box, and then its own connection to the internet. TV has its own cable, connection to the cable. And then I have like a stereo system independent, my laptop independent, and my camera independent. Means not network. Then people are thinking eventually, right now actually, they have products in the market. They have boxes that they connect you either to DSL or to the cable or through the modem. They connect you to, in one side, the cable modem comes in. At the other side, it's like a home router. Okay. At the other side, you can connect to 802.11 to your even cordless IP phones or your laptops or your printers or your networks, or you can connect through HPNA. So in one room to the other room, box comes to my second floor in my home. So I go to the third floor through HPNA, for example, because I have a PC fixed in there. First floor, I have my laptop. I use 802.11b. Okay. And then gradually, if needed, appliances and those things can communicate with that. Security systems can communicate with that. Today, what is sold in the market, they don't have it, but people are developing that. Further steps in the future, this is what people think. I have a distribution system which has many, many different means. This is not one means. Many different distributions. And I have many, many different devices. And then I have like a router in here, which is my home router, which does resource allocation. Means that this guy may have connection to cable, DSL, modem, everything. LMDS, DBS, 3G. And this guy decides on what is the most efficient way to do certain application. So I'm running one application, I'm browsing the web, and I'm bringing a lot of data. Then my children are using in another place the same connection. They see it's slow. Automatically, it goes to another connection. And some of those connections may have money. I mean, cost associated to that. So I need some like algorithm to work with that. This is like current stage of research, actually. And these are applied research in home networking. Challenges for home networking. Number one is handling the interference and coverage issues. Because if I have like now so many different techniques, I mean I have 802.15, inside home I cannot control. So I buy the device, I come in, it's 802.15, the other one is 802, they interfere. Number two is the issue of coverage. So if I go to the basement, still I can get certain type of signals or not. Or I have any connector actually in the basement, either power lines or like telephone jacks. So somehow I need to have that. The other one is designing inexpensive reconfigurable devices. These are for like these metering and things, RFID type of application. Little data rate, little power, and plug and play. Okay. Internetworking between different mediums. Incorporating cable TV. This is very important. That needs 25 megahertz and up, available all the time. Okay. Innovative, practical services. This is another challenge in here. This is very important, actually, to my opinion. Because this is the application which nurtures development of the industry. If you find like application that from distance from home is not like these imaginations that I was telling you. How many people are ready to pay $20 per month to turn on their microwave oven from distance? That's the point. How can you develop something that is a good business plan in there? Okay. So two of the areas that people think like distance home management possibly, and video audio streaming possibly, whatever. Anything in that domain is very important. And I often, when people ask me that what are really the applications in there, I say even if I knew that, I wouldn't tell you. Because if you knew an application which generates income, you open up your own company. This is as simple as that. Okay? Application runs the whole industry in the telecommunication. And with that, there are some references in here at the end. So I will see you guys next Thursday. And next Thursday, we start with first part of Lecture 3. Lecture 3, Lecture 4, and Lecture 5, 3 of them, are about technical backgrounds. First one is going to be about transmission techniques. The second one will be about transmission mediums, but variety of wires, how they compare with one another, and how do they compare with wireless. The third one is about networking aspects and TCP/IP suite. After that, we start the next series of lectures, which are going to be about standards, local area network standards. So next 3 is about background or technical aspects. So I'll see you next week. Thank you so much.